Hello, we're going to look at simultaneous equations now, and simultaneous means at the same time. So we're going to be dealing with multiple equations, usually two, at the same time. Before we do that, we're going to have a quick refresher on the meaning of being able to solve equations in general. So if we have an equation like x minus 7 is equal to 10, that means that we're claiming that x minus 7 is the same as 10. So if we had a weighing scales and we had x minus 7 sitting on the left-hand side of the weighing scales and 10 sitting on the other side of the weighing scales would be balanced. And when we are doing anything with equations, we need to keep them balanced. So we need to do the same thing to both sides. So if I want to solve this equation, by which I mean get x is equal to a number, that means I'm going to need to do the same thing to both sides. So I don't want this minus 7 here, so I'm going to add 7 to the left-hand side, and to keep my balance, I must add the same thing. I must add an equal amount to the other side. And when I do that, I get x must be equal to 17. X minus 7 plus 7 adds to 0. So I just have x on the left-hand side, as I want it. And I have 10 plus 7 is 17 on the right-hand side. And that's still balanced. I added 7 to this side and I added 7 to this side. So I have kept my balance. I have added an equal amount to both sides of my equation. And I can see that that doesn't break the equality. It doesn't break the balance. Now, if I have a different style of equation here, a function type equation where I have a relationship between x's and y's, now I have two letters in this equation. Unlike the first time where I just had an x and I could easily solve it, I can't solve this equation, L1, in the same sense. Line 1 I can't solve in the same sense because it has both an x and a y. It's describing a relationship. It's describing a group of points that all follow this pattern. So I can't solve it in the normal way. But what happens if instead of adding a number to both sides, I added another equation to my top equation? If I added L2 to L1, what would happen? Now, physically what this means, we will discuss in a minute. But let's just play this through and see what happens if I add these two equations together. So if I add L1 and L2, I'll get a 2x plus 3x is 5x. Minus 1y plus 1y is 0y, and I don't tend to bother writing down 0 of things, so I just have 5x on the left-hand side now, and 4 plus 1 is 5. Now I'm able to do this because in L2 I have 3x plus y is equal to 1. This is the same as this, the same way as 7 is equal to 7, so I can add it to both sides. So I've added an equal amount to both sides of L1, and in so doing, I have ended up getting rid of my y's. Now I have an equation I know how to solve. Now I can find out what x is. But this is a new equation. This is not solving L1 directly. This means something a little bit different now, and we will look at what it means in a minute. But I now have a value for x that I was able to solve from this new equation that I got from adding L1 and L2, because it got rid of my y's. They summed to 0. What happens if we take this x value and put it back in to L1? So I'm subbing x is 1 into my original equation. Now I have an equation that only involves y, and I know how to solve that equation. So I subtract 2 from both sides, get y by itself, is equal to 2. I can divide both sides by minus 1 in order to get y by itself. So 1y is equal to minus 2. So I now have a coordinate. I have x is 1, y is minus 2. What happens if I do the same thing with L2? So 3 times x, so 3 times 1 plus y is equal to 1. So I have 3 plus y is equal to 1. Subtract 3 from both sides, and I get y is equal to minus 2. So I get 1 minus 2 again. So what's happening here? Well, it helps to think again about what these equations mean. They're a relationship between x and y. They describe a set of points that all sit on a straight line. And we have those lines drawn in here. L1 is the red line going up here, and L2 is the grey line going down that way. What's happening at the point that we just found, at our 1, x is 1, y is minus 2? Well, if we go in the door 1 and down the stairs minus 2, what's happening to my two lines at that point? My lines are crossing at 1 minus 2. So what does that mean? That means that the point 1 minus 2 is on both of my lines, both L1 and L2. So that means that that's a point that's in both sets. So what do I call a point that would be shared between sets? It would be the intersection. So what can we say now? We could say that the intersection of L1, so our intersection symbol, our upside down U looking thing, or N if you prefer, for intersection, of line 1 and line 2 is the point 1 minus 2. X is 1, y is minus 2. So let's look at the steps that we will follow in general to get our intersection, to do our simultaneous equations. We want to write both equations in the form ax plus by equals c. Now this isn't terribly abstract. All it means is we write them in this form. We have the x and the y on the left-hand side, x and the y on the left-hand side, and the number, the constant, on the right-hand side. This just makes following the rest of the steps easier. If there are any fractions involved, we get rid of them. We never do any work with fractions with simultaneous equations. We multiply both sides of our equation by the lowest common denominator, and then we start doing the rest of the steps. We never do anything involving fractions with simultaneous equations. A very, very important rule for not making mistakes. And that's true of decimals as well. Only ever deal with whole numbers in front of your letters. Now, the next step we didn't have to do here because it was already done for us. We had minus 1y here and plus 1y here. So when we added these two together, we got 0y and we were able to solve for x. But most of the time, like in these examples here, we don't have the same number with a different sign in front of either our x or our y. So we have to multiply these equations so that if we have, say, plus 6x and minus 6x is probably what we're going to go for here. So when we add them together, the x's would sum to 0. We'll look at that in more detail in a minute. But we need to get this situation where we have minus something y plus something y, so that when we add them together, we get 0y, or vice versa for x. After that, we solved the equation, the simple equation that we had to get a value for x or y. And then we subbed that value for x or y into our original equations, and that gave us the point of intersection, and we wrote down the coordinate of the point of intersection of our two lines. So let's have a look at this in practice now. We have L3 and L4. L3 is given by this equation, L4 is given by this equation, and you can see I have labeled part 1 and part 2, or equation 1, equation 2. Keeping track of our simultaneous equations is really important because they can get quite complicated as we try to go through them. So we'll use this as a way to keep track of what we've done. So I can see L3 and L4 intersect at the point in the door 3, up the stairs 3. So when I do my algebra work now, I expect to get x is 3, y is 3 as my answer, because that's where my lines intersect, and that's what I get when I do my simultaneous equations. So let's see how we'll do this. If I just add these two equations together right now, like I did in my first example with L1 and L2, what am I going to get? I'm going to get 3x minus 2x is going to be 1x. 6 plus 3 is 9y is equal to 30. So at the moment, if I add my equations together, I don't get what I got this time. I don't get rid of one of my letters. So I can't just add them like I did the last time. It won't work. So what I need to do is multiply my equations to get what I had here. The same number as a different sign in front of one of my letters. And in this case, I'm going to go for x. Last time we did y. This time we're going to go for x. So I am going to aim to get 6x plus 6x in front of plus 6 in front of my ax up here and minus 6 in front of my x in L4. So that's what I'm going to aim for. I'm going to multiply both sides here by 2. So that I end up with plus 6x here. And if I multiply my second equation by 3, I'm going to end up with minus 6x. And I'm going to keep track of what I've done here. So this is going to be 2 times my first equation. It's going to be 6x plus 12y is equal to 54. And then we have 3 times our second equation. It's going to be minus 6x. So now I have plus 6x minus 6x. That's going to sum to 0, which is what I wanted. Plus 9y is equal to 9. And now when I add those two equations together, I get what I wanted. I get rid of one of my letters. So this is going to be my goal. I'm going to add them together now and get rid of one of my letters. So plus 6x minus 6x is 0x. Plus 12y plus 9y is going to give me 21y is equal to 54 plus 9 is 63. And when I divide both sides by 21 to get y by itself, I end up with y is equal to 3, which is what I wanted. Now I take that y and I go back into one of my original equations. I'm going to take the second equation, so I'll call that L4. I could also call it equation 2. And I'm now going to sub that in. So minus 2x plus 3 on 3 is equal to 3. So I have minus 2x plus 9 is equal to 3. Rearranging my equation to get x by itself. Minus 2x is equal to minus 6. Divide both sides by minus 2 to get x by itself. And I get x is equal to 3. So I got the equation 3 on the x, 3 on the y, as I expected. So the intersection of L3 and L4 from my graph and from doing it algebraically is at x is 3, y is 3. Now here, if I look at L5 and L6, my fifth line and sixth line, I immediately see I have a problem. I think back to my method. What's my first step? I need to have ax plus by equals c. My second equation here is not in that form. I have the y and the constant by themselves and the x by itself. So I need to rearrange this second equation, add 3y to both sides before I do anything else, so that I can follow through my steps. So I have minus 3x plus 4y is equal to 4y is equal to 14, and 2x plus 3y is equal to 2. And now I'm in a position to say this is equation 1, this is equation 2, and I can try and get the same number with a different sign in front of both of these. So in this case, we can get rid of the y's. So I'm going to get plus 12y in front of my y here and minus 12y in front of my y here. I could get rid of the x's again, but I'm going to get rid of the y's here just to demonstrate we can do either. Now when I get my equations where I plus 12y and minus 12y and I add them together and solve for x, I get minus 2. If I go down to my graph here for L5 and L6, I can see that that makes sense, so I'm happy to continue. And now I'm going to see if I get 2 for my y. And I see that I do. I have y is equal to 2 when I sub back into L5. Again, I could have also subbed into L6. It wouldn't have made any difference because we know the defining characteristic here is we get the same point. We get the same y value when we sub in that x value. So that means our intersection of L5 and L6 is happening at minus 2, 2. And that's what we need for now.